Our stats project asked the question, does telling people whether they are trying a homemade or store-bought cookie influence their decision when choosing which they prefer? In order to make the two types of cookies seem and taste relatively uniform, we use pre-cut store-bought cookie dough from Pillsbury. By using industrially made cookie dough, the likelihood that the ratio of ingredients was the same would be higher than if we had just made them ourselves, as the dough would be created in stricter ratios. We chose sugar cookies over chocolate chip ones in order to ensure each cookie was uniform, both in terms of taste and appearance. After baking, the cookies were randomly sorted into one of two containers, so that each container contained an equal amount of cookies and that any discrepancy between batches would be minimized. The experiment was conducted in the quad, where we stood and asked random students in the area to try the two types of cookies. We had subjects come up to us one by one so that their choices would be independent, regardless of whether they came from a larger group or not.
10 minutes, starting now.
Using a random number generator, unique random numbers from 1 through 50 inclusive were assigned to all 50 participants. Those assigned an even number were given the first treatment, that is, they were told which cookie represented the homemade cookie and which cookie represented the store-bought cookie. And those assigned an odd number were given the second treatment. They were not told of the cookies' designations, but were told that the dough for the cookies came from two different places. By separating subjects via whether their subject numbers were even or odd, we were able to guarantee equal sample sizes for both treatment groups. We also randomly generated a string of 50 random binary digits such that 0 designated that the subject would be offered the cookie made with the homemade dough first, and that subjects that received a 1 would be offered a cookie made with the store-bought first. This ensured that results would not be influenced by whether subjects preferred the first bite of the cookies or the last. After participants tried the cookies, we asked them to choose which cookie they preferred, discounting the results of those who said they did not have a preference. The subjects' choices were then recorded next to their subject number on a spreadsheet only the experimenters had access to. Our Group 1, the informed group, had 25 participants, and 15 of those participants chose the homemade cookie over the store-bought. In Group 2, we had 25 individuals as well, and 10 chose the homemade over the store-bought. As seen in the stacked bar graph, 60% of individuals in Group 1 chose the homemade, while 40 chose store-bought, and in Group 2, it was the opposite way around, where 60% chose the store-bought, while 40 chose the homemade. After conducting a 2-sample Z for difference in proportions and a 2-sample Z interval for difference in proportions, we found our p-value to be 0.157 and our confidence interval to be negative 0.072 to 0.472. Because the p-value of 0.157 is larger than 0.05, we cannot reject the null hypothesis at the significance level of 0.05. We do not have convincing evidence that the proportion of people that prefer the cookie representing homemade dough is different from the proportion of people that prefer the cookie representing store-bought dough, even when told the supposed source of the cookie. Supporting this, a 95% confidence interval constructed from the sampling data allows us to conclude that since 0 is present within the interval, there's insufficient evidence to reject the null hypothesis.